Hey guys, Mrs. Valatek here, your friendly AP chemistry teacher, starting you on your first AP lab, What Makes Water Hard, an investigation involving gravimetric analysis. The first part of this lab, what we are going to be doing is practicing our procedure, where our procedure will be applied later on in order to determine whether or not different samples of water qualify as being hard water. So in the first part of the instrumentation practice procedure, what we're going to be doing is making solutions of sodium carbonate and calcium chloride, then mixing the two together. So in the first step, it says for us to weigh about 2 grams of sodium carbonate into a clean, dry beaker. I happen to be here, and I'm trying to move the camera. Of course, it's not going to move. Okay, there we go. Come on, move. All right. At the analytical balance, maybe I can even zoom in a little, maybe I can't, maybe I can. And what I'm going to be doing here is measuring out the masses. Steps 1 and 2 are asking you to weigh out 2 grams of sodium carbonate, 2 grams of calcium chloride into clean, dry beakers. So I'm going to open up the window here for the analytical balance. I'll wait for it to stabilize, and I'll tare it. Then I'll open up the window. I have my sodium carbonate, and I'm going to add about 2 grams. Okay. 2 grams. In fact, it's 2.0238 grams, but that's neither here nor there because in the instructions it says that we are weighing about. The purpose here is to create a precipitate. I take my second beaker, which I've labeled as calcium chloride, and I'm going to add calcium chloride to it. I'm going to press tare now that it's stable, and I'm going to add calcium chloride. Again, they say roughly 2 grams. This is a little bit more. This mass is 2.1956 grams. Again, doesn't really matter because this does not have to be exact. In the next step, I'm going to take some deionized water, and to each beaker I'm going to add about 20 milliliters. Again, about is not an exact value, it's an estimate. This is close to 20. And then in the second beaker, which has calcium chloride, I'll add 20. All right. And now I'm going to stir and observe. It's going to take a moment for everything to dissolve. In the next step, I'm going to pour a small amount of the sodium carbonate solution into the calcium chloride solution. There it is. Stir and observe. Okay. What you can see is a white precipitate forms. I'll stir And I'll continue to do this until all of the sodium carbonate has been added to the calcium chloride. Okay. It's hard to see, but this is warm to the touch, most likely because the calcium chloride solution was warm. The dissolving process is exothermic. But this solid is kind of gel-like. Alright, stirring and observing. In the next step, I need to determine the mass of the filter paper. Using the analytical balance, the mass on the filter paper is determined to be 0.4697 grams. Now it's time to filter. I'm going to take my filter paper and I'm going to add it to my filter apparatus. I'm going to wet the paper with some deionized water from my wash bottle, and I'm going to turn on the suction. Now it's time for me to filter. I take my precipitate and I carefully add it to the filter paper. Slowly but surely. Take a moment and I rinse out my beaker. I also take a moment to rinse my precipitate with the ionized water. Once all of the water is through, I turn off the filter. I take a clean, dry watch glass. It's not dry. I'm going to have to dry it. But I would write my name on it if I was in a lab group, but because it's just me, I'm not. I will carefully remove the filter paper. Release some of the suction to make it easier. There we go. There's my precipitate. I'm going to put it on my watch glass and I'm going to go ahead and dry it in the oven. What would happen right now is that I would dry it, let it go for 15 minutes, weigh it, let it go for 15 minutes, weigh it again, and my goal is to get to a constant mass. Hey guys, I'm back. It's time for us to weigh our dried precipitate. So I'm going to go ahead and I'm going to show you. Here we go. The dried precipitate. Okay, and I'm going to try and zoom in if it's possible. It is. And I don't think you can see this mess, but I guess it really doesn't matter. So I'm going to zoom out because I'm just going to read it to you. All right, and it is time for us now to determine the mass. So if you take a look, and I have to be really careful because it's very flaky and dry. I'll open my door, make sure that my balance is reading 0, and I'll determine the mass of my precipitate. Okay, the mass is stabilized, and the mass of the precipitate plus the dried filter paper is 2.0126 grams. Hey guys, I'm back. And this time what we're going to be doing is we are going to be working through the inquiry portion of this lab. And there are going to be 2 groups. My hair looks bad. 2 groups carrying out this part so that we can have 2 sets of data. And it's going to really be the science teachers versus the amateurs. So in the first part, Mr. Gottlieb and I, or maybe Mrs. Webb and I, will be collecting data for 6 samples of, quote, community water. These are things that I've already made, so I know how much of the salt is in each of these samples. And they, quote, come from all of the places that are around us. So we have North Wales, we have Bluebell, we have Whitpain, we have the high school, we have Lower Gwynedd, and Ambler. Okay? What really is supposed to happen here is that you guys are supposed to design your own procedure, but I'm going to be the one who's doing it, and it has to be my procedure. So you guys are going to describe what I do in as much detail as you can. So really the concept behind here is quantifying the amount of calcium ions that are in each of these fake samples of hard water. And what we've learned is that calcium will precipitate in the presence of carbonate ions. So if I add carbonate ions, maybe in the form of sodium carbonate, I can precipitate out those calcium ions. I can collect that precipitate via vacuum filtration and dry, weigh, and measure it. So what I've done is I have prepared a solution of sodium carbonate that's in excess of what we are going to need in order to precipitate out all of the calcium ions. It's like a 20-fold excess, so it's pretty big, and we should be able to get it all theoretically. And from here, I guess you guys are just going to watch and write things down. Hey guys, here we are in the lab. Mr. Gottlieb.
Hi guys.
You can't see me, but you'll see me shortly. I just want to take a moment to show you that in order to be efficient, what I've done is I've set up all of these samples. I've labeled beakers behind them for the mixture. I've made my excess solution of sodium carbonate. I've gotten out all the equipment that I need. And now over here on the second table, what I've done is I've pre-weighed 6 filter papers and I've labeled them. We'll have a moment to see what their actual masses are. I'll read them to you eventually. And then over here, I've also gone and I've set up, or begin to set up anyway, our vacuum filtration system. So you guys can see it's connected to the sink here. Bernoulli's principle, turn on the water, it makes a vacuum, and that's really how it works. So we don't have a lot of time. We are going to get started. I have to zoom out a little bit, Mr. Gottlieb. So
Get my good side.
The first step in our procedure is to take our sample. So we'll take sample 1, which is from
North Wales.
and measure its volume in a graduated cylinder. What do you got?
42.6 milliliters.
Okay, 42.6 milliliters. We'll add it to the beaker that's labeled number 1. Okay, thank you. Now Mr. Gottlieb's going to take 10 milliliters of our solution of excess carbonate ions. That's good. And he'll go ahead and he'll add it. Terrific. We're going to give it a good stir here. One, two.
I could watch
Thanks,
this all
that's
day.
good. All right, I think we're good, Mr. Gottlieb. All right, we'll take it over here and we'll start to get ready for our filtration. Take the filter paper, put it in the funnel, wet the filter paper, turn it on. Is that on nice and tight?
I believe so.
I turn on the filtration. I turn the filter on first to make sure it's working. Make sure the water comes through. Yep. So I
Okay.
don't know if you can see it, but the water is coming through. Now it's time to carefully add it. Mr. Gottlieb's going to rinse, make sure we get all that precipitate out of the beaker. And once he's rinsed the beaker, he might even go a little bit further and rinse the precipitate on the filter paper. All right, what do you think?
Working well.
Crank it up. Let me know when you think it's done.
It'll be a couple of
Minutes.
minutes. Minute.
Once all the water is gone, we'll stop, carefully remove it, and dry it before we weigh it. Thanks, Mr. Gottlieb. Oh, hey guys, look at our first guest star. Woohoo! Say hello, Mr. Joyce. Thanks for coming in.
You have no idea what you're getting yourself into here.
All right, so Mr. Joyce, can you pick up the plastic bottle and tell me what the label says?
Okay, this plastic bottle says water number 3 Bluebell.
All right, so we're going to analyze Bluebell water here. Can you go ahead and open it and pour it into the graduated cylinder?
Okay, how much am I pouring in?
The whole thing.
The whole thing.
Okay, go ahead, and you want to get down a little low so that you're at eye level.
Okay.
And what do you say the volume is?
It says 45, what is that, milliliters?
Mm-hmm.
Okay, 45 milliliters.
Okay, 45 milliliters it is. You think it's exact?
It is not exact, it's a hair under 45.
So go ahead and estimate what you think that would be. 44 point.
44.8.
Perfect. 44.8 milliliters is our volume. Can you take that beaker with the number 3 on it? Nope.
Oh, the beaker. This one. Okay.
This is all
Yep.
so good because
Yep.
this is exactly what
This is
happens
what
in
you-
class.
This is what you get
Can
when
you
you
put
put
it
a
on the
social
hot
studies
plate?
person in here.
That's okay.
All right.
All right, please take what was in the cylinder that you just measured and put it in the beaker.
Okay. Without spilling it all over the floor.
Yeah, we're good.
Okay.
All right, now the right-hand knob on there, here on the yellow hot plate is stir. You can turn that on.
Does it matter how far I turn it on?
Just turn it to the middle. But no, it doesn't really matter. There you go. Maybe a little less. Maybe that's a little aggressive. There we go.
Okay.
All right, so now you're going to take your pipetter,
This?
yep,
Okay.
and you're going to take 10 milliliters of the liquid in the beaker next to it.
And it's right, sucks it up, and
Yep,
or
top sucks it up
and bottom puts it in.
Mhm.
So I'm going how much? 10?
to the 10. Yep, 10.
So up to the 0, right?
Yep. Good
A
job.
little bit
That's
over.
okay.
Is that okay?
Yep.
And then what am I doing?
You're going to empty it into the beaker on the hot plate.
Into here.
Mm-hmm.
Just all out.
All out. That's it. Can't mess
Oh,
it up.
That's cool. It's changing.
Yep. So what we just did was we made a precipitate out of all the calcium ions that are in there. So now I'm going to do this. What we're going to do, you can turn the stir bar off. So just turn that off and you can pick up the beaker and we're going to carry it over here. Okay. All right. So now what's going to happen, you can place it on the top, on the countertop, that's fine. You're going to take the filter paper that says number 3 on it.
This one?
Yep.
Right.
And you'll put it in the funnel.
Just drop it in.
Just
Right.
drop it in.
Kind of like a coffee filter.
Yep. Now you can go ahead and you can wet it.
Just damp or like
No, you
soap?
can put, it doesn't matter how much you put in there, but it definitely needs to be wet.
All right.
Okay, now you can go ahead and turn on the water knob, because that's going to start the filter. Yep, and turn it on all the way. Snug, and you can see, right, that there's water
Yeah.
coming through. Awesome. So what that means is that we're ready to filter. If you want to take what's the contents of beaker number 3, and you're just going to carefully, slowly add it to the top of the filter paper.
Yeah. I can do it.
You can do it.
So it's white when it's going in, but it's more or less clear coming out. Is that
Right.
fair?
That's
Is that,
right.
is that what we're supposed to
Because
see?
what we're taking away is the water, so we want to keep the stir bar in there. Now what you're going to do, I'll show you real quick. You're going to have it on an angle and you're just going to rinse. Yep. All right, that looks pretty good. Now we're going to give it a moment for all the water to pass through. Let me take a look.
Doing pretty good.
Still going, but that's okay. Once all the water passes through, we're going to rinse it one more time by just pouring some water through here. And then we'll be done.
So is this just creating a vacuum? Is that what it's doing?
It is. It is. So it's Bernoulli's principle. It's the same thing that works for a hose end sprayer. The fast-moving water creates a vacuum.
I think that's how we used to empty a swimming pool.
Yeah, yeah, it's true.
All right.
What do you think?
I
Time
think
for a
I gotta
little
add
washy
bit of
wash?
water. Yeah, just wash it down. Huh?
Yep, that's it.
I haven't blown anything up yet.
You did a great job.
This is still in one piece. It's not on fire.
All right, Mr. Joyce.
All right.
We thank you for your time. Great job.
Turn this off.
Until next. Yep. Oh, hey there, guys. Look, it's Officer Beth. She
Hey.
came to do an experiment for us. Officer Beth, would you mind to tell us which sample you're going to be testing?
I have water number 4 from Ambler.
All right. Thank
Yeah.
you. Could you start by emptying it into the cylinder and reading its volume?
Looks like we have 40.123.
So we have 43,
43.
and we think it's exactly 43, so we'll say 43.0.
I'm gonna say the bottom of the
Yeah, meniscus.
is meniscus. Thank you. Is just below the 3. So, all right. How about this? Can we do 42.5?
42.5 works for me.
Okay. Yes, ma'am.
All right, there we go. All right, so now what we're going to do is take the liquid in the cylinder and put it in the beaker on the hot plate. Yep. Okay, and we can turn the stir on. It's the knob on the right, maybe like a quarter of the way, just so that it's mixing. That's good. All right, so now what you're going to do is take that white and blue pipetter, and you're going to take 10 milliliters of that liquid in the cylinder, or in the beaker, I should say. Looks good.
Ooh. All right.
Okay, now you're gonna add it to the stirring.
In here?
Yep. And look at that.
Ooh, what's happening?
That's a white precipitate. It's forming between calcium ions and carbonate ions. So now we're going to let that stir for a second, and we're going to come over to the filter apparatus and get it ready. So we're going to find the filter paper that says number 4, and we're going to put it in the white funnel. You can squirt some water on there. Excellent. And you can turn the water on. Turn it on all the way. There we go. So we can see that the water's coming out. All right, and now we're ready to filter. So what we're going to do, there you go.
Thank you.
All right. Just try not to add the stir bar in. So the stir bar I want to stay behind. There we go. And actually, I have something you can use. I'm gonna just stick something on the bottom here so that it won't ever come out.
Oh, look
Now
at
you can
fancy,
rinse out.
fancy
Uh-huh.
science.
You
You
can-
learn stuff.
You can rinse your beaker. So we're gonna, remember we're
Oh,
going to.
right.
You can, hold
Gotcha.
on, hold on. Just keep that on, and then you don't have to worry about it coming out.
Right, okay. Rinse this and pour it back in to
Yep.
get all that good stuff down there?
Yep. All right, that looks pretty good to me.
All right.
Now, once all the liquid passes through, we're going to add a little bit more water to make sure that the filtrate is clean. So, you can add some water. Just rinse it off. There we go. Like that. All right. And then once the water passes through, we're done. All right, Officer Beth. Thank you so much for coming in. We'll
Thanks,
see
guys.
you
Good
soon.
luck.